Hello everyone, and welcome to The Explainer. Today, we're diving into a genuinely fascinating investigation into the hidden physical architecture of modern computing. We're going to strip away those glossy software interfaces we all interact with every single day, and we're going to descend all the way down to the bare metal. We're going to uncover how the systems running our world actually operate underneath it all.
Have you ever stopped and wondered how a messy, abstract human thought safely translates directly into physical reality? I mean, think about it. We type a simple line of code, it floats up into the cloud, and somehow it commands a physical machine in the real world without the entire sequence just completely crashing. We intuitively feel like computers just kind of get us, right? You click a button, something happens. But bridging that massive gap between our beautifully chaotic human intent and the strict, unyielding reality of a physical processor, that is an incredible mystery and, honestly, a monumental engineering challenge.
Okay, let's dive into this because this technological divide actually mirrors a macro-level economic clash. It honestly reminds me of Jimi Hendrix's 1967 masterpiece, Castles Made of Sand. You know, how fragile things eventually just melt into the sea? We are seeing exactly that right now with these speculative empires of hype. On one hand, we have the liquidator VC approach. It operates like an extractive casino, building fragile castles of short-term bets and treating founders like disposable lotto tickets. But on the other hand, we have the legitimacy VC model, acting more like a 10-year venture architecture lab focused on sustainable, mathematically verifiable infrastructure. And what's truly mind-blowing here is that this massive sociological clash between fragile hype and solid anchored infrastructure is perfectly mirrored by a microscopic flaw right inside our computer chips.
To understand that flaw, prepare to have your assumptions about perfect computer math totally challenged. 80 to 90%. That is the percentage of modern AI compute cycles that are actually not exact mathematics. When these massive language models are doing their heavy lifting, they aren't handing you an absolute ground truth calculation. No, they are fundamentally just running hardware-level approximations. They're guessing the nearest answer that's hardwired into the silicon, just to cope with the overwhelming volume of continuous data. It is quite literally a digital castle made of sand, built on a foundation of probabilistic guesswork.
And relying on these approximations triggers something absolutely devastating known as the wood chipper effect. See, when the hardware probabilistically guesses the math, instead of strictly calculating it, the original identity and provenance of that data are irreversibly destroyed. It's basically a giant digital blender. You might know exactly what fruits you tossed in, but you can never, ever perfectly reverse engineer that smoothie back into the original apples and bananas. The exact mathematical lineage, that all-important chain of title, is completely obliterated. You lose the ability to track who contributed what.
Kyle McLean Smith really hits the nail on the head in the source material, stating, "It's fundamentally an approximation system, not real arithmetic. You simply cannot build a system of perfect digital trust, or a 10-year sustainable venture architecture for that matter, on a foundation that is basically just throwing darts at a dartboard. It's just way too mathematically and sociologically fragile."
So we really have to recognize the massive modality mismatch causing this whole issue. We're trying to force human thought, what researchers call wet code, which is beautifully fuzzy, associative, and full of continuous meaning, into the dry code of bare metal silicon. The hardware is unapologetically cold, rigid, and driven entirely by strict clocked voltages. There are no semantic symbols down there. The machine is completely blind to our meaning.
Now, what's really interesting about this is how computer chips process this reality using two radically different components. First, you have the FPU gambler, or floating point unit. It's wildly fast, but it's lossy and probabilistic. To achieve that blistering speed, chip manufacturers literally burn completely secret proprietary seed tables directly into the physical silicon to help it guess the math. Then we have the precise antidote, the ALU surveyor, or arithmetic logic unit. The surveyor is a bit slower, sure, but it is strictly deterministic. It acts like a surveyor out in the field with a precision laser, dealing only in absolute, verifiable hardware truths. Without the ALU surveyor acting as our solid bedrock, all the mathematical and sociological complexity we build up top is really just another fragile castle made of sand.
But because modern AI relies almost entirely on the FPU gambler, we pay a massive compounding cost. Relying on those hidden corporate trade secrets leads to non-deterministic drift. Since different machines use different secret tables, those tiny rounding errors violently compound over billions of concurrent AI operations. Ultimately, this leads to a total loss of forensic accountability. We end up wandering in what the sources call an automated miasma, just a foggy, untraceable mess where absolute truth is permanently lost to the machine's relentless guesswork.
So the crucial point is this. If we want to reclaim sovereign compute, we have to shift our core logic away from the fragile guessing of the gambler and hand it over to the solid rock of the ALU surveyor. The arithmetic logic unit simply refuses to guess. It performs exact verifiable arithmetic where 1 + 1 equals exactly 2 on every single CPU on Earth. It acts as a globally accountable, undeniable universal witness, providing the absolute hardware determinism that we actually need for real digital trust.
But how do we tame the blistering speed of the FPU without losing the exactness of the ALU? I mean, we can't just slow everything down to a crawl, right? Well, forward-thinking developers are using ingenious speculative scheduling frameworks like the LLM42 DVR wash cycle. It's a brilliant three-step protocol. First up, decode. The AI uses the FPU for a rapid speculative guess. Second, verify. A separate mechanism takes those guesses and locks in the exact mathematical parameters using the ALU. And finally, rollback. If the fast guess doesn't perfectly match the exact verification due to that floating point drift, the system forcefully, deterministically rejects the bad data. By constantly washing the FPU's microscopic rounding gunk through the exact ALU, developers can literally extract perfect precision from total chaos.
Now, pushing this exact deterministic execution back to decentralized networks requires better tools. The standard Ethereum virtual machine environments have their own limitations and constraints. That's exactly where alternative virtual machines come into play, like Arbitrum Stylus. Stylus brings multi-VM functionality to the table, breaking the boundaries of solidity and allowing developers to write highly efficient WASM and Rust contracts directly alongside the EVM.
And this brilliantly illustrates why this architectural shift is such a massive game changer. Benchmark data from LimeChain proves it. When executing heavy, purely computational exactness, like an ED 25519 signature verification, using Arbitrum Stylus with Rust is actually 75% cheaper in gas costs than using traditional EVM Solidity. It completely proves that demanding absolute mathematical truth at the local hardware level isn't just theoretically more secure, it is significantly, quantifiably more efficient when you utilize the right programming languages. You really don't have to sacrifice performance for truth.
But to safely force our messy thoughts through this exact hardware, we must cross what researchers call the semiotic bridge. Think of this as the universal deterministic interface of structured text. By using explicit structural text boundaries, we can safely compile our fluid, fuzzy human imagination directly into the rigid, uncompromising execution of the hardware's arithmetic logic unit, leaving absolutely no room for algorithmic distortion. So let's see how this is actually engineered in reality. To build this bridge safely, developers are bypassing bloated smart contracts in favor of real surgical precision. They use lightweight tools like ERC 787 value version control to anchor the digital state. By using an insanely efficient last-in, first-out ledger that only checks a single recent entry at index 0, you get immediate mathematical proof without dragging through massive, heavy transaction histories. And by relying on dormant webhooks through Chopsticks design, they avoid unnecessary complexity to achieve total determinism. And here is the ultimate payoff of crossing that bridge, the Flow X42 Cheerbot. Picture a little robot sitting right on a desk reading that perfectly verified, bit-perfect JSON state from the LIFO ledger. When the tip clears, it literally translates pure math into raw electrical signals fired directly into its tiny GPIO pins. Pure, abstract mathematical logic becomes tangible, physical movement, shocking the machine into action without relying on any centralized, guessing intermediaries. It is just flawless execution, straight from the cloud, right down to the desk. This entire architectural shift, from guessing gamblers to exact surveyors, really presents a massive, unavoidable choice between two wildly contrasting roles. You could be a cloud tenant. That's someone who passively rents their cognitive capabilities from an invisible centralized tech monarch. When you're a tenant, you act as a moral crumple zone, absorbing all the brutal legal and ethical impact when the algorithmic gambler inevitably hallucinates and makes a statistical error. Or you could be the sovereign pilot, the individual who takes absolute agentic control, owning their local hardware substrate and demanding exact, verifiable execution from the metal. Same input, same output every single time. Because when you strip away the marketing hype and all that philosophical magic, you arrive at a profound realization. We are quite literally tricking rocks into thinking using lightning and text. There is no magic ghost inside artificial intelligence. The machine doesn't feel joy, it doesn't face biological friction. The true creative spark, the intent, The actual magic of authorship is 100% human. The machine is simply a deterministic brush, sitting completely blind, just waiting for your exact command. So, as we continue to build these massive digital architectures, and hopefully try to avoid building fragile castles made of sand, I want to leave you with a final, highly provocative question. As the great enclosure of the cloud attempts to wall off your digital reality, will you quietly rent your capabilities, passively absorbing the machine's guesswork? Or will you saddle up your own hardware substrate, demand absolute truth from the bare metal, and ride as the sovereign pilot? The choice is entirely yours. Thank you so much for joining me for this explainer, and as always, keep questioning the systems that run our world.